everyone. In this video we are going to discuss few questions of the functions. So let's start. The first question is, the following diagram shows part of the graph of quadratic function f. The vertex is at 3 minus 1. So this point is 3 comma minus 1 and the x-intercept at 2 and 4. So x-intercepts are 2 and 4. The function f can be written in the form of fx is equal to x minus h whole square plus k, and we know from here that the maximum value, or we can say vertex is given by h comma k, means this is the x value for which we will get the minimum value in this case, because here the curve is upside down. If this is the same thing, quadratic curve, and you are getting a equation fx as k minus x minus h whole square, and in that case again h comma k will be the vertex, but in this case it would be maximum. So let's compare it and find the answer. So write down the value of x. So h is going to be 3 in this case, and k, the minimum value, is minus 1. And next part is, the function can also be written in this form, and we know that the x intercepts are actually known as the roots of the quadratic curve, and from here if we solve fx is equal to 0, we should get two roots, and those two roots are actually 2 and 4. So we can compare it and we can write directly from here that fx is equal to x minus 2 into x minus 4, or a is equal to 2 and b is equal to 4. I hope it is clear. Now the C part is, find the y-intercept. Y-intercept means where this curve cuts the y-axis, and we can see it cuts here. So the y-intercept is 0 comma 8. This is the y-intercept. I hope it is clear. So let's do the next part. So here is the question number 2. Let fx be px square plus 10 minus px plus this, and show the discriminant. We know that if the fx, a quadratic graph, is given as ax square plus bx plus c, in this case the discriminant d is given by b square minus 4ac. So we can compare. So we can see this is a, this total is b, and this total become c. So discriminant d is equal to 10 minus p whole square minus 4 times a, that is p, into 5 over 4 p minus 5. We can simplify it further. It is 10 square, that is 100, minus 2 into 10 into p, that is minus 20 p, and plus p square, that is a minus b whole square identity I have used, and then if I multiply here, 4 will be cancelled and it becomes 5 p square, and minus plus 4 5s are 20, and it is 20 p. So we can see these two will be cancelled and we are left with plus p square minus 5 p square. So it becomes 100 minus 4 p square, and hence proved. This is what we need to show. I think it is easy. Let's do the b part of it. In this we need to find the values of p, so that fx is equal to 0 has two equal roots. So fx is equal to 0 will give the roots, and if they are equal, so we know the properties, the nature of the roots, we get it from the discriminant. If this is greater than 0, then there are two distinct roots. If d is equal to 0, then they are equal roots, and if d is less than 0, so no real roots. So we will be only talking about this. So here for equal roots, d should be 0. We can write for equal root d should be 0, or 100 minus 4 p square is equal to 0, or we can translate it other side, it is 4p square, or we can write it as p square is equal to 100 over 4, that is 25, and hence the values of p become plus minus root 25, that is 5. So these are the values of p. So they have given the question in this way, that what is, find the values of p. So there are two values. So let's discuss the next question. Here in this question number 3, given is fx is given as this, x square plus x minus 6. Write down the y intercept. So y intercept means on y axis x is equal to 0. So we can say y intercept is x, that is 0 comma f of 0. So 0 here, and f of 0, if we will put x is equal to 0 here, we will get minus 6. So the y intercept is 0 comma minus 6. Now the next part is on the following grid, sketch the graph of f from minus 4 x from minus 4 to 3. So we have got two values. One value is what is y intercept. So y intercept is 0 comma minus 6. So 1 is here, I'll change the color. 1 is here, 1 point is here now, and 1 point is here, and for the x axis, point on the x axis, we will find the roots of it, and we can see that for the roots we will be solving fx is equal to 0, that is x square plus x minus 6 is equal to 0, or we can directly write it as, we know that the two numbers by which if we will multiply we will get 6, and by subtraction we get 1, it would be plus 3 and minus 2. So the roots are x is equal to 2 and minus 3. So the other 2 points are points on the x axis will be these 2 points, minus 3 and 2, and we can check on the boundaries endpoints, like at x is equal to minus 4. So it is going to be f of minus 4, we will find it is going to be 6, because fx is x square plus 6 plus x minus 6. So at minus 4 it would be 16, minus 6 is 10, and 10 minus 4 is 6. So it is 6, and f of 3 is also 3 3s are 9 plus 3 12, minus 6 is 6. So we got these points, and we know the nature of graph, it is upside down. So we can join these points and we will get the curve. I have drawn it here. So this is the curve of fx is equal to x square plus x minus 6 from minus 4 to 3. See, I marked all the points which you need to join it. Now let's do the question number 4. Question number 4 is the equation x square plus k plus 2x plus 2k is equal to 0 has two distinct real roots. So again, distinct real root means d should be greater than 0, discriminant should be greater than 0. So we need to find the possible values of k. So d is b square minus 4ac, it should be greater than 0, or we can compare here, and a is 1, b is k plus 2, and c is 2k, and we will replace the value here. We will get k plus 2 whole square minus 4 times 1 times 2k greater than 0, or we can say it is k square plus 4k plus 4 minus 8k greater than 0, and hence we can write it as k square minus 4k, because plus 4k minus 8k is minus 4k plus 4 is greater than 0, and we know that it is a square minus 2ab plus b square. So it is k minus 2 whole square greater than 0. So we know that this square number is always greater than 0. So we know that square number is always greater than 0. It means this is always going to be greater than 0. So the possible value will be all values which this can take, and hence k can take any value, or we can write k belongs to real number, or we can say k is greater than minus infinity, less than infinity. It can take all the values. For example, if you want to understand more, so if you put k negative, let's say minus 4, so minus 4 minus 2 whole square, this is minus 6, that is 6 square only, which will be greater than 0. And if I take k is equal to 5, then 5 minus 2 whole square is 3 square, that is also greater than 0. So it is true for all the values of k. So the solution is k will be either we can write k belongs to real number, set of real numbers, or k is in between minus infinity to infinity, all the values of real numbers. So let's discuss the next question. Number 5, the equation x square minus 3x plus k square is equal to 4 has two distinct real roots. So two distinct real roots, again d should be greater than 0, and we can compare a, b, c, and we will get b square, that is 9 minus 4 times 1 times k square is greater than 0, or we can say 9 I can write it as 3 whole square minus 2k whole square is greater than 0, and we can use a square minus b square formula, that is 3 minus 2k into 3 plus 2k, a minus b, a plus b greater than 0. Now we can see the graph is like this cap, and the roots are, you will get the roots from here. The roots are minus 3 by 2, and from here it is 3 by 2. So in order to get the curve, this will give you the area region which you want. Greater than 0 means we require this curve, this part of the curve, and for which k should be in between minus 3 by 2 to 3 by 2. I hope it is clear. So let's discuss the sixth part. Sixth part is consider two different quadratic functions of the form this. Two quadratic functions. The graph of each function has its vertex on x-axis. Vertex on x-axis means we are going to we can say that they are having the equal roots, because vertex is on x-axis means this is touching the x-axis at one point. So vertex is 1, and hence there will be only one root. So for that d should be equal to 0, discriminant should be 0, and this means q square, b square means q square minus 4 times 25 should be is equal to 0, or we can say q square is equal to 400, and hence q become plus minus 20. So the values of both possible values of q is q is equal to 20 and minus 20. I hope it is clear. Let's do the b part of it. B part is for the greater value of q. Greater value means q is equal to 20. Solve this. So we are going to write 4x square minus 20, because q is 20, so minus was already there, plus 25 is equal to 0. We can see 425 times is 100, and 10 into 10 is 100, so it is going to be 4x square minus 10x plus 25 is equal to 0. I'll take 2 common, so it is 2x common, so we are left with 2x minus 5 from here. Again 5 common, so it is 2x minus 5. So we got 2x minus 5 whole square is equal to 0, means they are equal roots, and equal roots means x is equal to 5 over 2. So this is the solution of fx is equal to 0 for q is equal to 20. So for the c part, it's like find the coordinates of the point of intersection of two graphs. Then from here we can see fx is going to be 4x square minus qx plus 25, and for both the value of q, we can say that one thing is for sure, that what is f of 0. F of 0 is 25 in both the cases, for k is equal to 20 and for k is equal to minus 20. For both f of 0 is equal to 25, then we can say directly that these two graphs will meet at x is 0 and y is 25. They will meet at 0, 25. So let's discuss the next part. So here the question number 7. express y is equal to 2x square minus 12x plus 23. So we'll do by completing square method. We'll rewrite y is equal to, I'll take 2 common from first 2, that is x square minus 6x plus 33, and now we know how to make the complete square from these two, and that is going to be x minus half of 6, that is 3 whole square, and subtract the square of this number, that is 3 square plus 33. So it becomes 2 times x minus 3 whole square, 3 3s are 9 into 2 18 minus 18 plus 33. So it is 2 times x minus 3 whole square plus 13 minus 8 15, it is 15. So this is done. Now next part in this question is y is equal to x square is transformed into the graph of y is equal to this by transformation, a vertical stretch with a scale factor k and horizontal translation and the vertical translation. So we should know that if fx is given function and there is a vertical stretch, then it means it should be of the form a times f of x. This is the vertical stretch by a unit, a factor, scale factor. And horizontal translation, we know that if it is fx, then in that case the horizontal translation is given by x, f of x minus a, and vertical translation, the third one, vertical translation is given by f of x plus a. So it's being followed by previous one. So we can say that first of all x square stretched, so it become k times x square, and then k square is being horizontally translated by p unit, so it is k times x minus p whole square, you can see x minus p whole square, and then the last one is vertical translation by q unit, so it would be k times x minus p whole square plus q, and this is the new y. And we know from the first part y can be written, this can be written as 2 times x minus 3 whole square plus 15, and hence k become 2, p become 3 and q become 15. I hope it is clear. So thank you so much. We'll see in the next video.